Good morning, everyone. So, in the previous lecture, we covered the middle term expansions. Okay, the binomial chapter. Okay, so today we'll start with the greatest binomial coefficients. Okay, so let's start now. So we are starting with the greatest binomial coefficients. Okay, so in the binomial expression or the expansion, the binomial coefficients of middle terms are called the greatest binomial coefficients. Okay, basically we will be talking about middle terms. Okay, so here some cases are given, like first, if n is even, if n is even, so when r is equals to n by 2, that is n c n by 2, so it takes maximum value. Second is n is odd, so that is r is equals to 1 minus n minus 1 by 2, or n plus 1 by 2, so that we called it as ncn minus 1 by 2 is equals ncn minus 1 by 2, and it takes its maximum value, right? Let's look out at one example. So we have to find the greatest coefficients expansion in 1 plus x to the power 2n. Okay, so here we know greatest coefficients is equals coefficients of middle term, right? So it becomes 2ncn, that is equals 1 into 3 into 5 goes up to 2n minus 1 divided by n factorial n, multiply with the 2 to the power n. So this becomes your answer. Okay, so with this, first copy this page. Okay, sorry. Okay, so let's look at one more question. So the term question given, the term which has greatest binomial coefficients in expansion in expansion of x square plus 2 by x to the power 6 is. Okay, so here we can see, first we know that the binomial coefficients of middle term is the greatest binomial coefficient. Okay, So here we can write n is equals to 6, which is even, right? So middle term will tn by 2 plus 1, right? So we can write middle term is equals to n by 2 plus 1. So that is 3 plus 1, which is fourth term. And this becomes your answer. Moving to the next topic. Okay. So here now we need to determine a particular term in the expansion. Okay. So in the expansion of x to the power alpha plus minus 1 upon x to the power beta power n. If x to the power m occurs in tr plus 1, so then r is given by n alpha minus r alpha plus beta is equals to m. So that means r is equals to n alpha minus m alpha plus beta. So in the above expansion, if constant term, that is the term which is independent of x, occurs in tr plus 1, then r is determined by n of alpha minus r alpha plus beta is equals to 0. So this equals n alpha plus of beta. Okay. So this is for the r. Okay. So next is coefficient. of x to the power 39 in expansion of x to the power 4 minus 1 by x cube power 15 is. Okay, so here, uh, as we seen that formula for the r, so we'll use that. So r is equal 15 into 4 minus 39 divided by 4 plus 3, which is equals to 3, right? So the required term, which becomes t4, is equals 15c3 x4 power 12 minus of 1 by x cube power cube, so which becomes minus 455 x to the power 39. So coefficient of x to the power 39 is equals minus 455. So this becomes your answer. Okay, next problem. The term independent of x in expansion of under root 1 by 3 under root of x power 9 is equals to what? Okay, so here we can see tr plus 1 is equals to 9cr 6 under root x 9 minus r minus 1 by power r. Okay, so here we can check out 9cr minus 1 to the power r into x to the power 9 minus r by 6 minus r by 3, right? So that equals 9cr into x n minus 3r by 6. So now we can see 9 minus 3r is equals to 0. So where r is equals to 3, so t is equals minus 9c3. Uh, let's talk about the next question. The term independent of x in expansion of 4 by 3 x cube minus 3 by 2x to the power 9 is. Okay, so solving as 3 by 2x power 9, with we can say x to the power alpha plus minus 1 upon x to the power beta power n. Correct. So here we get alpha is equals to 2, beta is equals to 1, n is equals to 9, and r is 9 into 2 by 2 plus of 1. So here we can say 6 plus 1, which is your seventh term, is independent x of x. Okay. Okay. So next is we'll be finding numerically greatest term in the expansion. Okay. Numerically greatest term in the expansion x plus a to the power n. Okay. So let tr plus 1 be the greatest term from the x plus a to the power n. So here tr plus 1 and tr is greater than equals to 1, and tr plus 2 and tr plus 1 is less than equals to 1. So here we can say tr plus 1 and tr, so that becomes ncr x to the power n minus r a to the power r. So n minus ncr minus 1 x to the power n minus r minus 1 and a to the power r plus 1. So it becomes n minus r plus 1 divided by r a by x. Correct. So here we can see n minus r plus 1 divided by r mod of a by x greater than equals to 1. Correct. So next or n plus 1 divided by r greater than equals to 1 will become x by a plus of 1. So r here you can write it as n plus 1 divided by mod of x by a plus of 1. Okay, so here if we talk about the algorithms, first you need to calculate this the last step. Okay, and you can measure it with the k is some constant. Okay, if k is an integer, then tk and the tk plus 1 are the numerically greatest term. If k is not an integer, let m be its integral part, then t m plus 1 is the numerical greatest term. Okay, so first you can copy this, then we'll look out at one example. Okay, okay, then copy these two. Okay, so here you can take k also. Okay, for the m plus 1 divided by x plus a plus of 1. Okay, and apply the whole modulus for it. Now I will write the algorithm for this. Okay, to solve the problem. Okay, so first step, calculate n plus 1 mod of x by a plus 1, which is equals to k. Okay, step 2, if k is an integer, then tk and tk plus 1 are numerically greatest term. Okay, and second is if k is not an integer, then let's m be its integral part, so that tm plus 1 will be greatest numerically term. Okay, so you can copy these 2 points. Okay, then we'll look out at one example related to this. Okay, example, if a sum of coefficients in expansion of 1 plus 2x to the power n is 6561, then the greatest term in the expansion, greatest term in expansion for x is equals to half is. Okay, so here given is x plus 2x to the power n is 6561, so that is 1 plus 2x to the power n, which is 6561. So when x is equals to 1, so 3 to the power n, so 6561. So 3 to the power n, 3 to the power 8 is where n is equals to 8. So tr plus 1 tr, so it becomes 8cr 2x to the power r, 8cr minus 1 2x r minus 1. So that becomes n minus r by r into 2x. Correct? So that can be written as tr plus 1 divided by tr, which is 9 minus r by r. So x is equals to half. So tr plus 1 divided by tr, which is greater than 1. So here you can write n minus r by r is greater than 1. So 9 minus r is greater than r. So here you can write 2r is less than r 9. So r is less than 4 into half, right? So you can say hence fifth term is the greatest term. Okay, fifth term is the greatest term. Okay, so with this we are going to wind up the session here. Okay, we'll continue in the next lecture. Thank you.